We are going to explore the plotter module in Fitteia. There are several things you can do to improve your graphs, especially if you want to include them in a report. For example, since the fit has very few parameters, we could include the obtained value in the case-free region of the graph. This way we save space in the report because there is no longer a need to include a separate table. Before going this, we need to mark the value of k and d naught along with their uncertainties and the appropriate number of significant figures. So k is 1.3 plus minus 0.2 kilonewton per meter and d naught is 1.0 plus minus 0.3 centimeter. Notice that d naught has an uncertainty of 0.3 even though the digit after the 2 is 0 because uncertainty should always be round up. Now let's go the plotter. The plotter module and import the figure from Fitteia by clicking of import button. As you can see, there were some issues with importing certain title characters, but we can simply go to the title region and make the unnecessary correction. If we click my plot, we can see this issue has been fixed. Next, let's include the value of fitting parameter in the region. To do this, we need to introduce a string. Let's use this one. K1 is equal to 1.3 plus minus 0.2 kilonewton per meter. To start the new line, we use lower case backslash and d naught is equal to 1.0 plus minus 0.3 centimeter. This is how you can write the plus minus character backslash c, enter the special character mode, and backslash capital C, exit it. Another thing I like to mention is that if you want to reduce the font size, which is what I initially did, you need to use backslash minus. However, you must also include backslash minus every time you use backslash capital N because backslash capital N reset the font size setting. Now let's include the string and position it at x is equal to 0.5 and y is equal to 0.04. If we click my plot, we can now see the parameter with their value display on the graph. Another thing we can do is make the part of the line not supported by experimental data. This is important because we do not know if the string can withstand 4 kg without alternating its elastic properties. How do we do this? We need to divide this line into two parts, one up to approximately 3.5, which will remain the solid, and another part behind 3.5, which will be dashed. I will make advantages of the fact that is dataset corresponding to the line is represented. We will see why in a moment. So the first dataset will draw the solid curve up to 3.5, meaning we need to delete the part behind the point. The second dataset will only draw the curve from 3.5 onward, so we need to remove the earlier portion. Now let's check in if everything is consistent. This value here defines the thickness of the line. It is a solid black and has thickness of 2. For the second part, we will set it into the dash since it represents the portion not supported by experimental data. The first part will remain solid and black with the same thickness of 2. When we click on my plot, we can see that the part of the curve not associated with any experimental data has been made dashed. This way we avoid making assumptions about what might actually happen in this region. Now let's save this graph that we have been working on. We will give it a name different from the folder name. For example, plot1 and archive. You can see that the file now appears here. The file you save in the plotter module only appear in this module. They do not appear in Fitteia. So to recover this file, you need to enter the folder, open the plotter module for that folder, and select the file from the menu. You can also tutorial 1 folder where the plotter module has several templates for your project. To explain why the dataset corresponding to the line was repeated, let's go back to the Fitteia module, and we will click find the curves link below the graph. Yeah, on there. The second and third column are identical. There's a feature in Fitteia that allow you to separate different contribution in the module. If you use slash plus at the bottom, you can separate the corresponding ones is a constant d naught and other is a line with slope g over k. After that, if you click compile, it will be reverse this area where you can control the appearance of these two contributions. Let's label it as G over KM. And to avoid confusion with the total fit line, we will change the appearance and color of the line. After clicking fit, you will get the same fitting result, but Fitteia will also draw the separated contribution. Here, the constant d naught and the line with slope g over k passing through the origin. Now if we go to curves, we will see there are no repeated columns, and in the center we have the separated contribution. Here the value are equal to d naught. The contribution g over km is here, and here is the sum of these two. No more repetition. We can import this graph into the plotter in the same way. If we go to the plotter, click import, we have it. Of course, there's still an issue with the title, but you know how to fix it. You can save it as plot 2. We have now only plot 1 to avoid confusion. Now that we know how extract curve, let's experiment a bit more. Let's replace G with the moon G, then click plot. Let's extract the black curve with which is C1, C4. As defined by the first and fourth column, we will create a new dataset, my plot, and although nothing seemed to happen, we now have a new dataset below. Select C1, C4, then click calculate, but nothing show up because by default the dataset type is XYDY and we need XY, and it does not have any symbol or line assigned. Let's choose a solid line. Violet. If we click my plot, now we can see XY. Yeah. Solid line is color and my plot. We can see. Now let's try G is equal to 10. Click plot, extract the curve, create the dataset, and click my plot. This can be blue, then click calculate. These lines recognize themselves really well, but it's always good to use label which are here. So this one will be G is equal to 9.8, and the data set corresponding only the dash part of the previous. Here we have G is equal to 1.62 and here G is equal to 10. Let's place the legend at 3.2 or 0.03, and if we click my plot, and we label every dataset, 0.2 and 0.003 and click on my plot. We will now see the labels. There are a few small details we can improve to make the graph easier to read. First, we can make the label appear in the order in which the lines appear, meaning the blue lines label should come first, followed by the black lines label, and lastly the violet line label. Another thing we can do is make the graph more accessible for those who print it in the black and white or use devices that do not read color. What can we do? We can combine line and symbol. Usually different lines type are combined, but since we already have the dashed lines to repeat the part of line that is unsupported by experimental data, we will combine lines and symbol instead. To change the order of label, we need to record the dataset because label appear in order of dataset. The first one should corresponding to G is equal to 10, which is dataset 2. So G is equal to 10 will become dataset 2. G is equal to 1.62 will become dataset 5. And G is equal to 9.8 will become dataset 4 instead of dataset 2. After doing this and click my plot, we will see that label will be in a sequence with the lines. Is 4 and my plot. Yeah, we are changing the sequence. After that, we need to see the label, and we also add symbol to the curve. For example, we will use square for the 10 G is equal to 10 curve in blue and not filled, and a diamond for G is equal to 1.62 in violet and filled. When we click my plot, we will be able to see the curve not only by color but only by symbols. If the blue and black curve are too close, you want favor symbol, you can go Fitter module and select the lower number of points for the theoretical curve. If you draw the theoretical curve with only 50 points, there will be fewer symbols. Remember that if you change the scale in plotter, you will need to redraw the curve. For example, if the set the scale of 7 instead of 5, the click my plot, the curve would not extend behind the point. That point, I would have to regenerate the curve to match maximum of new scale by adjusting the scale into the fitter as well. Finally, we will see this graph as plot 3. Yeah, it's plot 3 and archive. Imagine now that you want to refer to a specific region of the graph into the text of your report. One easy way to do this by that graph with vertical and horizontal lines. For example, additionally, your model could have vertical and horizontal assumptions, and sometimes it's useful to draw those lines as well. Let's draw a vertical line with x is equal to 3, extending across entrance scale from the point 3, 0 or 3, 0.05. The next, let's draw the horizontal line, but only for example from 1 to 0.03 and 4 to 0.03. We will add two new datasets. For the vertical line, we will use the point 3, 0 and 3, 0.05. And for the horizontal line, we will use the point 1 and 0.03 and 4, 0.03. We will select very separate line style for both. If you want to plot a function that cannot represent by just 2 points, you can generate a list of points. For example, if you want to compare the theoretical model with experimental data, the fitted curve, you could draw the theoretical function here. Let's create a 8 dataset and generate a list of points. Since x goes from 0 to 5, we will want a list of points from 0 with a step of 0.05 up to 5. This will generate a column of value from 0 to 5 with the step of 0.05. And C1 will appear. So C1 square, you cannot write C1 square this way, but you can use the POW and parenthesis function. In function, you can write base C1 over 10 to fit the scale and exponent, then choose the line style after click calculate. We will have all the guides we draw. Don't forget, this approach for handling exponents also applies to fitter module. So if you need to fit a polynomial, use this function. Let's save the project as plot4. And we will write C1 over n. Yeah. Calculate. Yeah. We could easily remove these guides by changing the number of dataset to 5. And click archive. Click my plot because it will remove the last 3 dataset we added. However, if we don't want to delete them, we can simply hide them by selecting the hide option in the small menu. If you click my plot, you will see that the guides have disappeared. After this extensive tutorial, I believe you are now in the position to explore the plotter module more independently, and I am sure it will be very useful to you. See you in next video.